Rescue project had its aim at evaluation of the links on the fly concept in theory and practice, which included diverse activities carried out by the project partners. In realistic performance evaluation, we were following the strategy of a step-by-step complication of the test environment, while gradually bringing it closer to real field communication scenarios where links on the fly could provide potential gains. At the first step, parts of the project concept were implemented in software by partners from the universities of Oulu, JAST, AGH, UNIS, TU Dresden and UBTech Company. This software was used to simulate physical and MAC layers functionality and investigate hardware-independent performance of the links on the fly approach. The algorithms have then been transferred by the FQS Poland to GNU Radio Framework to allow real-time operation of the system on top of the software-defined radio platform called USRP. After verifying the software implementation, we switched over to the lab experiments in a controllable environment. Colleagues from TU Ilmenau have carried out conducted communication using channel emulator to perform reliable hardware-in-the-loop tests and have the first understanding on how the rescue concept and its implementation would work over simplistic radio channels, such as AWGN and one-tap channels. Some more details on this step are presented in the previous video. Finally, during the third step, we conducted over-the-air communication in real environments. AGH have taken care of an indoor communication scenario in office environment, while TU Ilmenau has overtaken the experiments in outdoor vehicle-to-vehicle scenario. This video is aimed at giving an insight into the preparation and conducting the real field experiments on V2V communication. Motivated by the specifics of the dynamic outdoor scenario, the testbed developed at Technische Universität Ilmenau for the rescue vehicle-to-vehicle measurement campaign has got the following features. The testbed is transportable as one piece, yet it is powerful enough to execute rescue software at the rates similar to those of the desktop PCs. It is easy to roll out the rescue nodes by just plugging to a power supply, attaching antennas and accessing the node's software remotely. The nodes can be powered from different sources such as 230 volts AC or 12 volts DC from an onboard car battery or an external battery. USRP local oscillators are tightly synchronized with the offset of less than 50 Hz for the carrier frequency of 2.53 GHz using GPS-driven external oscillators. The testbed is capable of collecting additional metadata during the measurement, such as the GPS coordinates of the node and wide-angle photographs of the environment. Each node can be remotely managed over the internet, while the testbed automatically establishes the connection to the internet over a 3G, Wi-Fi or wired network and dynamically switches between these channels if one becomes unavailable. The testbed assists the car driver by announcing the current status of the measurement in voice messages, just like in a standard GPS navigation system, such that the driver is aware of the current activities of the remote operator. Similar to other activities during conducted lab tests and in indoor office scenario, during the V2V experiments we focused on the Toy Scenario 1 rescue system topology while using Toy Scenario 0 for calibration. Outdoor experiments for Toy Scenario 1 were conducted in a stationary and dynamic modes. In the stationary case, the relay to destination link was established as error-free, while the other two links, source to destination and source to relay, were deliberately set to be lossy to investigate the links on the fly concept. In the dynamic measurement, the quality of all the three links were significantly changing in time, since the source and the destination node were moving around the TU Ilmenau campus in the following way. The source node, placed in Volkswagen Charan, started at the barrier on the plan below and rode towards the crossing. The relay node was mounted in the Range Rover, parked next to the crossing and remained stationary during the whole measurement. The destination node inside the Volkswagen Golf started from the opposite end of the campus and also draw towards the crossing. Eventually, all the three nodes would meet near to the relay position, emulating the ITS G5 crossing scenario. At this time, all the three radio links would have very good quality and rescue would bring no gain. Then the nodes would drive away from each other and at some point appear in a communication scenario, which we call rescue region of operation. Here, the links on the fly concept is expected to bring some gain by combining several lossy copies of a frame to recover their payload. Later on, as the source and destination nodes drive further away from each other, the direct communication link between them is dropped. The only communication path remaining is the one over the relay. Finally, one of the cars is so far from the crossing that the communication drops completely. As it makes a U-turn and starts driving towards the crossing again, the communication is re-established. Here, the scenarios for the cooperative communication are changed in roughly the opposite order. The source and the destination always stay on the animated track, moving counterclockwise. The communication between the nodes was managed and monitored remotely from a control room. The three console windows for the source, relay, and destination respectively, with a roughly 1 second lag, showed real-time status messages for each of the rescue nodes. These status messages were simultaneously stored as log files for future post-processing. Preparing and conducting the vehicle-to-vehicle measurement campaign at TU Ilmenau has proven to be quite challenging and time-consuming, and we would like to use this opportunity and express many thanks to our colleagues from partner institutions as well as from the Fraunhofer IIS and Bagov company who assisted us in preparation of the experiments and post-processing of the collected data.